Today we're going to talk about factoring. So we have 4 different types of factoring we're going to talk about in this class. The first one we're going to talk about is factoring out the greatest common factor. This is the biggest number and letters, or numbers and variables, that go into all of the terms of the algebraic expression. So for example, 9x cubed y squared plus 3x squared y cubed minus 15xy. So we're going to look at each of those terms and determine the biggest number and the highest power of variable that goes into all 3 of those. So as you can see, 9, 3, and 15 are all divisible by 3. They all have at least one x, and they all have at least one y. So the greatest common factor would be 3xy. Now factoring is the opposite of distributing. When you distribute, you multiply. So when you factor, you divide. So when you factor out this 3xy, you're going to take each of the terms in the parentheses, each of the terms that we started with, and divide it by 3xy. So 9 divided by 3 gives us 3. X cubed divided by x leaves us with x squared. Y squared divided by y leaves us with y. Do it to the next term. 3 divided by 3 is 1. We don't have to write the 1. X squared divided by x is x. And x cubed divided by y is y squared. And then we'll do it to the third term. Negative 15 divided by 3 is negative 5. X over x cancels, y over y cancels. Now when you factor, you can always check that you factored correctly by redistributing what you ended with and making sure you got what you started with. So we'll take that 3xy times 3x squared y plus xy squared minus 5, and we'll distribute it out. So we'll take 3 times 3, x times x squared, y times y, to get the 9x cubed y squared. 3 times 1 is 3, x times x gives us x squared, and y times y squared gives us that y cubed. And then 3 times the negative 5 gives us that negative 15, and then we carry the x and the y. Notice we got what we started with, so we know we factored correctly. Another example, 30m cubed n to the 4th minus 24m squared n cubed plus 6m squared n. What do they all have in common? They are all divisible by 6. They all have at least an m squared, and they all have at least one n. So the greatest common factor would be 6m squared n. So remember, we're dividing. 30 divided by 6 is 5. M cubed divided by m squared is m. N to the 4th divided by n would be n cubed. Negative 24 divided by 6 would be negative 4. M squared over m squared cancels. N cubed over n leaves us with n squared. Now this is important. A lot of people like to forget and end the parenthesis here. However, 6 divided by 6, don't forget, that is 1. M squared over m squared is 1. N over n is 1, so you do need that 1 filler there. The next type of factoring we're going to talk about is grouping. This is when you have 4 terms. So for example, 7x cubed minus 14x squared plus 2x minus 4. With grouping, what you're going to do is you're going to group the first 2 terms together and the second 2 terms together with parentheses. Always make sure that in the middle you have a plus. If this was a minus, then what you would do would be add a negative, and you would carry the negative with this term in this group. Now you're going to look at each group individually, 7x cubed minus 14x squared, and factor out the greatest common factor. Then we'll do 2x minus 4 and factor out the greatest common factor. And when we do that, 7x cubed minus 14x squared has a 7x squared in common. We're left with x minus 2. 2x minus 4 has a common factor of 2. When we pull out a 2, we're left with x minus 2. Now these 2 terms have an x minus 2 in common. So you can factor out that x minus 2, and when you do, you're left with 7x squared plus 2. Remember, with factoring, you could always redistribute it out and make sure you get what we started with. Let's look at another grouping. 8t cubed minus 12t squared minus 10t plus 15. Group the terms together, but if we group it, you're going to notice that's going to be a minus in the middle, so we'll change that to adding a negative 10. Then we'll group the 8t cubed and the 12t squared together, the negative 10t and the 15 together, and factor out the greatest common factor. 8t cubed minus 12t squared, when you factor out the greatest common factor, it's 4t squared, and you're left with 2t minus 3. Well, over here, if we factor out just a 5, we'd be left with negative 2 2t plus 3, but we need it to be 2t minus 3, so we'll factor out the negative with it. Factor out the negative 5, negative 10 divided by negative 5, we're left with 2t. 15 divided by negative 5, we're left with the negative 3. Now both of these terms have the same thing in common. They have 2t minus 3. Factor out the 2t minus 3, and you're left with 4t squared minus 5. Now we're going to talk about trinomials. There are two different types of trinomials, the one where the leading coefficient is a 1 and the one where the leading coefficient is not a 1. So we'll take it one step at a time. So we'll talk about the trinomials where the leading coefficient is a 1. That's your x squared plus bx plus c. This is going to factor into two groups of two binomials. X plus a number times x plus a number, where m times n is going to give you this c, and m plus n is going to give you this b. So for example, x squared plus 7x plus 10. We need to find two numbers that multiply to get 10 that add to 7, 2 and 5. So this factors into x plus 2 times x plus 5. Again, you could FOIL this out or distribute this out, and you'd see we get what we started with. Keep in mind negatives. M squared minus 12m plus 35. Two numbers that multiply to get 35 that add to negative 12. If they're going to multiply to get a positive and add to get a negative, that should tell you they're both negative. And we get negative 7 and negative 5. The next type of trinomial is the one where you do have a number in front of the x squared or y squared in front of the squared term. So here's what we're going to do. We're going to take this a and this c and multiply them together. So 3 times 15 is 45. Then we're going to find two numbers that multiply to get 45, that multiply to get that a times c, that add to b. So two numbers that multiply to get 45 that will add to 14, 9 and 5. 9 times 5 is 45, 9 plus 5 is 14. So we'll rewrite the equation using those values. So we're going to break up this 14y using 9 and 5. So 3y squared plus 9y plus 5y plus 15. We didn't change anything because if we combine like terms, 9y plus 5y would give us that 14y. And now we will factor by grouping. Group the first two terms together, 3y squared plus 9y. Group the second two terms together, 5y plus 15, and factor. Factor out the greatest common factor here is a 3y. The greatest common factor here is a 5. And look, they both have a y plus 3 in common. Pull that y plus 3 out, you're left with 3y plus 5. Again, you can distribute it out and make sure you get what we started with. Let's do another one. 2x squared minus 7x plus 6. Multiply a times c. So 2 times 6 is going to give us 12. Now we need to find two numbers that multiply to get 12, that add to get this negative 7. Look closely. They're going to multiply to get a positive and add to get a negative. So that tells us they're both negative. Negative 3 times negative 4 gives us a positive 12. Negative 3 plus negative 4 gives us that negative 7. So we're going to rewrite the equation using those values. 2x squared minus 3x minus 4x plus 6. Now we group the two terms together. Group the first two, group the second two. Remember, this needs to be a plus sign, so we'll turn it into adding a negative. So when we factor out the greatest common factor here, it's just an x. The greatest common factor here, we're going to factor out that negative 2 to make them positive so that they match. And when we do, we see they both have a 2x minus 3. When we factor out that 2x minus 3, we're left with x minus 2. The last type of factoring we're going to talk about is the difference of two perfect squares. A perfect square is something you get by multiplying something to itself. For example, 1, which is 1 times 1. 4, which is 2 times 2. 25 is 5 times 5. 36 is a perfect square. That's 6 times 6. Keep in mind variables can be perfect squares as well. X squared is x times x. X to the 4th is x squared times x squared. X to the 10th is x to the 5th times x to the 5th. So any variable to an even power is also a perfect square. The formula For a squared minus b squared, the difference of two perfect squares, you take base 1 plus base 2 times base 1 minus base 2. So let's do a couple of examples. X squared minus 25. X squared is a perfect square, that's x times x. 25 is a perfect square, that's 5 times 5, and we are subtracting. So this will factor into base 1 plus base 2 times base 1 minus base 2. X plus 5 times x minus 5. Okay, let's look at one more example. 36x squared minus 49y squared. 36 is a perfect square, x squared is a perfect square, so 36x squared is a perfect square. 49 is a perfect square, y is a perfect square, so 49y squared is a perfect square, and we do have a difference. So this is going to factor into 6x plus 7y times 6x minus 7y. Now we're going to try to get a little practice doing this factoring on our own, but what we're going to do is we're going to extend it a little bit, and we're going to factor completely. What it means to factor completely means you're going to factor until you can't factor any further. So you're going to go through, the first thing you're going to want to do is factor out the greatest common factor if there is one. Then, if you have 4 terms, try factoring by grouping. If you have 3 terms, see if one of the trinomials fits. And if you have 2 terms, see if it's a difference of 2 perfect squares. And each time you factor and you get your little groups together, your parenthesis groups, you look at each of those parenthesis groups and you say, is this a trinomial? Can I factor by grouping? Is this the difference of 2 perfect squares? And you go through and factor until you answer no to all of those questions, and then you know you factored completely. Okay, see you tomorrow.